Now, let's finish this up. Then you guys will have a work day to do the three problems that you have for to finish for curve sketching before we move on to the packet for tomorrow. So let's go back and think back to what we did today or yesterday in the notes, and then we'll complete them by drawing the graph. Okay. So first thing we did, we took the original graph or the original function, and we obviously distributed here. But then we found the derivative by doing the quotient rule, right? Low d high minus high d low, all over low low, because low low is correct. And we got 20x over x squared minus 4, all that squared. Did the second derivative and got negative 20 times the quantity of 3x squared plus 4, all over x squared minus 4 cubed. Okay. And then the next place, we're just starting to get some pieces. So x-intercepts, plugged in 0 for y. Y-intercepts, plugged in 0 for x. And got our answer. We got 3 points, 3, 0, negative 3, 0, and 0, 9 halves. We found our asymptotes, vertical at negative 2 and 2, horizontal at y equals 2. Okay. Then we did our critical numbers. Okay, so set the first derivative equal to 0, critical number of 0, but also at negative 2 and 2 because of the asymptotes. Points of inflection, set the entire thing equal to 0. There was nothing that made the top equal to 0, so there was no other values to add except for the ones that were at the asymptotes, that we made the bottom equal to 0. So then we created this big chart. Okay, 3 rows, original. The reason we don't have these filled in is because those don't tell us anything. There's no information to give, and we'd have to fill in a lot of points there, and the points could change. Okay, so that's why we're not going to fill anything else in for the original function. Okay, we will though where the exact points that we were given, so the asymptotes and the critical numbers. And if we had points of inflection, we would actually add those in yet too. Okay, so just kind of remember for that. Second row is the first derivative. Okay, so now we're doing our test, first derivative test. Where is it increasing? Where is it decreasing? Plug in test values. So if you remember back to yesterday, plugged in negative 3 and we got a negative sign. And again, I was using a TIA calculator with my y equals to plug all 3 of these in, so I could do it pretty quickly. It's nice if you could make it ask you, so go to second table set and then change it to ask. Then you can plug in the values that you want. You don't have to try to look them up and down. Okay, plugged in 0 and got 0, so that just tells me that at 0 is a relative max or a relative min, and we can actually see that it's going to be a relative minimum because we go from decreasing to increasing. Okay, so I actually know right here, let me get my pen, I know right here that point is going to be a relative min. Again, because I'm going from decreasing, my line is going to be going down to up. That means this has to be a minimum point. Okay, so that's why we know that. So then with increasing, got to the asymptote, then was still increasing from there on out. The second derivative test tells me concavity, like what shape does my U go? Okay, think about, is it facing up, facing down? First interval, facing down. From negative 2 all the way to 2, it's facing up. Okay, and then after the second asymptote, it's going to be facing down again. So what we need to do is we need to put all these pieces together in order to draw a sketch of our graph. Okay, it's very good and a very good idea for us to write out what every interval is doing so that when we draw our picture, we have clear of what it should look like. Okay, so write those pieces down like we did yesterday. All right, so I'm going to probably scroll off of this so I can't see my chart anymore, but you should have it in front of you with your notes. If not, pause this and get your notes out. All right. Let's see. Is it going to let me scroll any farther? Yeah, there we go. All right. Insert doesn't let me draw a drawing line. Here we go. Let's do this one. Okay. Now mine will be perfect. There is graph paper along the back wall under the golf clubs, and I would suggest probably using that. I did that on my notes. It'll just make things a little bit neater, but again, some of you want to keep it in your notes, so it's up to you. All right, so first thing I did is I drew my asymptotes. So at negative 2, vertical asymptote. at +2 vertical asymptote. Wow, that was hideous. All right, and then at the horizontal asymptote is at +2 on the y-axis. So those are lines that cannot be crossed. Okay. Other points that they gave us were the ones that we found were the x-axis. Just kidding. The x-intercepts and the y-intercepts. So -3, 0. Right here, I know this is a point, and 3, 0. I know this is a point. I also then know 0 and 9/2, which is 4.5. So 3, 4, and let's do a half right here. Okay. So now I have all my points. Now I have to take the rest of that table and I have to put it into use. Okay, so what's happening? All right. So here's what I know. From -infinity, so from over here, you can see my little cursor hopefully, over on the left-hand side of the screen, I'm going to be coming in and I'm from all the way up until -2, I need to be decreasing. So my line needs to be going down. Okay? And I need to cross -3, 0. So pretend that touched really nicely. Okay. The other thing that you can need to check is your concavity. If that would look like a U, if you would make that continue to look like a U, would it be facing down? It looks like it would. Okay. So I have an asymptote at -2, so nothing happens there. So from -2 to 0, it looks like it's okay. So it's decreasing. So it has to be going down, and then it has to go through the minimum and then change direction there, all the while being concave up, right? If you look at your chart or your table, the second derivative from -2 to 2 is all pluses. So that means it needs to be like a quadratic function facing up. So that's how I know it has to be up here, okay? Because I can't cross my horizontal asymptote, and then it needs to go back up, okay? So I would be decreasing. My graph would be decreasing from here to here, okay? And then after that, after it goes to the minimum, it would be increasing, which is exactly what the first derivative test told me, okay? So last part of this then is from +2, the second vertical asymptote, to infinity, and it's increasing. That means the line is going up as I get closer and closer to infinity, but I also know that I have to go through the point 3, 0. So there we go. Whoa. Pretend that didn't happen. All right, so let me erase that. Actually, let's just do it the easy way. Redraw that. I apologize. I'm sure you guys are loving this right now, making fun of me, but that's okay. All right, so there we go. So, and again, check concavity. Is it facing down? If I would make that U shape, okay, again, you guys see me do it with my hand in class. Check it. Does it look like it's facing down? And it does. Okay, so just a reminder, take the original function, find the first and second derivatives, find your intercepts, find your asymptotes, find your critical numbers with the first derivative test, find your points of inflection with your second derivative test, and then make a table that looks a lot like mine. Okay. If you get points of inflection, so we didn't have any on this problem, but you need to include those in your intervals. Okay, so just be careful with that. All right, I will stop there. You have the rest of the period then to work on the homework. I don't remember, I think it's page 212, 9 through 13 odd. So you only have 3 problems. Use graph paper to draw your sketches, and just be neat, take it slow, work together. You guys have got this. I believe in you. All right, have a good day.